Welcome back. This is an Aleks training video on drawing a box diagram of the electron configuration of an atom. Okay, there's a lot here, so I'll try to be as clear as I can. There's several kind of things going on. You want to know not just where an electron is, but you want to know how much energy that electron has. So you are going to be asked to find, in this case, neutral atom of carbon. What's the electron configuration? Where are the electrons? What orbitals are they in? What energies do those orbitals possess? Okay, so if you remember, let's look at the periodic table again. You should always have a periodic table. Okay, so if I'm wanting carbon, which is here, what have I filled? Okay, I have filled the 1s, and it's done. So now I move to n equals 2. I fill the 2s. Okay, that gets me as far as beryllium. And now I'm in the 2p, but I'm only going as far as carbon. Okay, so I want 1s, 2s, and 2p2. Okay, all right, so 1s2, 2s2, 2p2 is the address of that carbon. That's the electron configuration. Now the box diagram is an electron configuration. Okay, 1s has the lowest energy level. So if you remember what we did in a previous lesson here, to where you went through 1s and then 2s, then 2p, then 3s, then, I missed this one, 3p, then 4s, then 3d, and 4p. So you're going from 4s to 3d. That's weird because you're doing 4s before 3s, but scandium is in 3d1, but calcium is in 4s2. Calcium is in the s subshell, and 3d is next. So you just keep doing in this increasing order. So the first one that I came to was 1s. Okay, and remember, this is an orbital, which is a room with 2 college girls in it, and each college girl is the electron. So that's one orbital. The next orbital with the next energy has to be the 2s. Okay, so the 2s has more energy. I'm going to put a box here. So that's the 2s. Then the next one that we had was the 2p. Now the 2p, remember, p is L equals 1, and the orbital rule is 2L plus 1. So 2 times 1 is 2 plus 1 is 3. There are 3 orbitals here. In the 2p, there are 3 orbitals. So this is 2p. Now there's a rule called the Hunds Rule, H-U-N-D, Hund, which means that if possible, if you can give each of these girls their own room, do it, because they hate each other. But they will not take their own room if they have to go to a higher energy level. They'll share as long as it's cheaper. But if it's the same price, you want to give them their own room, because they don't want to double up if there's an opportunity to not double up. They don't want to be together. All right, so the fourth quantum number, remember, is spin. One is spinning left, one is spinning right. So you're going to indicate that by an up arrow and a down arrow. An up arrow is going to have a positive spin. A down arrow is going to be a negative spin. Okay, so now carbon. Carbon is number 8. That means there's 8 electrons, and I have to account for 8 electrons here. All right, so the first electron I'm going to put in is in the 1s subshell, and it's going to have an upward spin. The next one is still in this low because they want the cheaper room. So now it's going to be, here's 2. Okay. Okay. So I don't want 8, I want 6. I was like, I'm making a mistake. Carbon is 6. I'm asked for carbon, sorry. Neutral atom of carbon. So I want 6 arrows. So the first 2 is the up arrow and down arrow in 1s. And then the next one is the next cheaper room. 1 arrow, up arrow, down arrow, and 2s. Now I've got 2 more to do. This one is the next one. the up arrow and 2p, but Hunds Rule says don't give two girls one room when there's extra rooms at that price. All of these have the same energy, so I'm going to give you the second girl, the carbon, the second room. So this one will have her own room and this one will have her own room. These two have all doubled up because these are cheaper, the next cheaper, next cheaper. They're always going to go for the cheapest room. And if there's 3 rooms or 2 rooms or 3 rooms or 5 rooms or 7 rooms that are at the same price, you split them up before you're forced to double the next one up. Okay, so this is the electron configuration box diagram of a neutral atom of carbon. Okay, probably need to practice a few of these to get good at it.